today to an overview of the 61511 Process Safety Sector Standard and cybersecurity. Hope you can see my screen okay. Looks like my screen has paused for a minute. Okay, so I would like just to start by introducing exida, just for those who don't know exida. Exida is a company that's been around for the past 17 years, and we are a global company. We were formed to help with cybersecurity, functional safety, and alarm management in the process industries and several other industries. Over the years, we've grown substantially, and now we operate across a number of industries such as the automation, the automotive, the nuclear, and the process. And we work with manufacturers, helping them with their management support for functional safety management, their certification for their products, and also providing tools to help them through the design process. From the system designers, we again help with the functional safety management side. We can do the SIL verification for them and also supply tools. For end users, there's full safety lifecycle support for facilitating PHAs and LOPAs, etc. and providing tools to help them with collection of data, such as the SIL stat. And then the engineering contractors, we work with them to help them with competence development and getting their people certified for the CFSE or the CFSP, and also provide tools. We also produce a lot of reference materials, and our website has a lot of information that's also free. So I do encourage people to go to www.exida.com and have a look at the resources that are there. One of the things that we do provide is a safety automation equipment list. So if you're looking to design with certified devices, that's a good place to go to look and see what type of devices are available. And there's also a number of white papers that we have through there with the resources, as well as these webinars, which are actually recorded and then stored as little YouTube videos that you can revisit whenever you want. And there's a variety of topics, and they go back over several years, so there's quite an archive built up. The other thing we do is publish books, and those books are available through the web store if you're interested in buying them. So we have authored quite a few books, and we do regularly publish papers, which we put up on the website as well. If any of you follow us on LinkedIn or Twitter, we also do quite a few blogs on various subjects covering functional safety, cybersecurity, and alarm management. So again, I encourage you to look at those. From the certification point of view, we have, as part of exida, which is an independent company within exida, certification. So we do product certification to 1508. We also do the cybersecurity certification of products to the 62443 standard, or the Achilles, the old Achilles 1 and 2, and the ISA Secure. We also do personnel certification, and we have our certification program run by the CFSE board, and that's for the Certified Functional Safety Expert, Certified Functional Safety Professional, and now we have a Certified Controls and Automation Cybersecurity Expert. So if you want to get certified on cybersecurity now, you can do that too. I apologize for my voice. It keeps giving out for me. Just a little bit about me. some of you have listened to me before on the webinars. I'm responsible for our global business development as well as our end user services for functional safety and cybersecurity. I've been with exida for about 4.5 years, but overall I have nearly 40 years of industrial experience in safety and controls. My background is as a designer of safety system products, and I was with a company called ICS in the UK, which is now part of Rockwell, for many, many years. Excuse me. I am a member of the IET, still in England, and I've published papers on managing risky projects, conforming to 6.15.11 operation and maintenance requirements, and concurrent engineering, reducing time to market. I also, one of my other hats is to be a trainer and run the FSC course. And for those of you that are interested, just a little ad here, we are running another open enrollment course in Warwick in November from the 14th. We still have places available, so if you're interested, please contact Ali Coles in our UK office, and she'd be happy to help you. Okay, so what we're going to do is look at, as a brief reminder, the standard and how that has been changed to include cybersecurity. As you know, the 1508 is what's known as the umbrella safety standard. That first released in 2000 and then was updated in 2010. It then spawned sector standards, as we call them, and the IEC 6.15.11 is the process industry sector standard. That too has just been updated this year, and one of the primary changes was to include cybersecurity. As we know, over the last few years, or last several years, cybersecurity has become increasingly more relevant, especially after Stuxnet. And the point about these standards is that they're performance-based, they're not prescriptive. And so the whole point here is that you be following best practice. And COMA in the UK and OSHA in the US require operators of hazardous processes to follow the best practice. And IEC 6.15.11 SAE4 is recognized as being RAGAGAP, which is the recognized and generally accepted good engineering practice. So that's really what best practice is. And 15.11 itself was built around a safety life cycle, much in the same way as 15.08 was designed. And the three main phases of that is the analysis phase, where we look at hazards, do the risk analysis, look at our layers of protection, do a layer of protection analysis, and then come up with a initial design for and our initial safety requirement specification. Then we go into the design and implementation, where we create the actual design, detailed design. We do the SIL verification to make sure that we meet the requirements, and then we move from that into doing our testing and validation, and then from there into the installation, startup and commissioning and startup. The point of the safety life cycle is to make sure that we don't repeat problems from the past, where we have sometimes expensive over-design and other times expensive under-design. So the whole point is to give you a consistent approach to how you identify and mitigate risk, and also as a means of providing an optimum design that balances again your risk with your performance, your risk reduction with your performance. The other thing is, it also provides you a means to consistently measure performance, because that's the whole point. If you're going to have a performance standard, you need to have some key performance indicators to be able to measure performance. Interestingly enough, the HSE did a study in '93, and then they did it again in 2003 to look at the primary causes behind accidents. And what they found is that 44% was due to bad specification, and then 15% was down to design and implementation. So here again, the issue is that if you don't design correctly at the beginning, you're not going to end up with a design that meets your requirement. And like most things, with safety especially, if you don't design safety in at the beginning, it's very difficult and expensive to add it in later on. The same with the cyber. If you are designing with cyber in mind, then it's better to do it at the front end rather than the back end. And the whole purpose of this and these performance-based standards is to help you achieve an optimum design, but to also manage and reduce wherever possible problems regarding systematic faults. And systematic, some people say systematic is due to the human factor, but basically it's what we call the 3 Ps. It's the paperwork, processes, and the people. So in other words, if your people aren't trained, if your processes aren't good and your procedures aren't good, you're going to end up with poorly implemented designs, missing requirements, and worse still, you may end up with a lower SIL rating than you actually need. Shell also did a study to see where the life cycle successes came from, and what they found was 49% of safety functions were over-engineered, 4% safety functions were under-engineered, unsafe, and 47% no change. So clearly the 49% over-engineered means that you're going to end up with expensive designs that are hard to maintain and going to cost you money moving forward. The 4%, although small, is still a concern because they're still unsafe, and 47% no change. So again, when we look at the standards, we see that 1508 was designed to target suppliers of process control and instruments for use in safety applications. And the whole point here is end users should seek products that have been certified to this standard, because part of that certification is to also look at how the manufacturer is dealing with or handling potential systematic issues. So do they have good processes and procedures? Do they do design reviews? Do they have competent people? Is their manufacturing process quality good? Do they test well? Have they had many field returns, etc., etc.? And the same is true from the cyber point of view. Again, what we're looking to do is make sure that the product that is being designed can be immune to certain cyber attacks, whether intentional or unintentional, such as hardening of ports. If you have a device that has an Ethernet connection, then you want to make sure that the device is hardened so it can withstand storms on the network and can prevent the product from behaving in an erratic fashion. 1511, of course, is targeted at the end users, and those end users can be engineering contractors and integrators as well. Similar to this 1508, it has the life cycle, the 3 phases, and it is performance-based, not prescriptive. So again, we need to have good key process indicators of how to measure performance and clearly see whether our design is working or not. The other thing with the end users is that they're not typically certified. Now, engineering companies can have their processes and procedures certified to 1511, and some of them have done that already. But from the end user point of view, they can't do that, and so what we do is we have independent functional safety assessments. The purpose of these is to help mitigate against systematic problems. So if we look at the life cycle, the first thing we do is process hazard and risk analysis. And this is where 1511 has been changed. 1511 now has a new clause to cover the cybersecurity. So what 1511 now says is that what you need to do is you need to carry out a security risk assessment to identify your security vulnerabilities of the SIS. So of course, the ideal time to do this is when you're doing your initial PHAs, when you're looking at your overall hazards, this is a good time to look at your potential vulnerabilities of your SIS. And of course, this implies that you have an SIS, and so obviously under OSHA and COMA, every 5 years you have to go back and revisit your PHAs. So since the standard was updated this year, it now behooves end users to, next time they go back and do their PHA reviews, is to go back and do their cyber. It's obviously a good idea to do that sooner rather than later, but if you're close to your 5-year cycle, then that's a good way to do it. The point being that you do a risk assessment, and then what you have to do is you have to define the devices that are going to be covered by the risk assessment. For example, if you have a process control network and you have your SIS connected to it and your BPCS connected to it, or gateways or anything else through to your wide area network, your plant network or your management network, then you need to make sure those devices are covered by that risk assessment. The premise in safety is that we look at strength and depth. So we have layers of protection. The same is true in cyber. It's all about defense in depth. How many layers can you put in there to help and defend the system from any intentional or unintentional cyber attacks? A lot of people think that cyber attacks come from somebody sitting in a university in China or somewhere in Iran or somewhere in North Korea. But actually, most of the incidents have been due to internal issues, disgruntled employees. So part of the issue is not just protecting from the outside in, but protecting from the inside. So that means that you need to have policies and procedures regarding how you screen your employees. For example, the Shamoon virus that Saudi Aramco got hit with, it took down 30,000 machines, and it was actually due to a disgruntled employee. He introduced the virus. So it's important to understand what devices are connected and then to include them in the risk assessment. And then you need a description of the identified threats that could exploit vulnerabilities and result in security events. So in the past, before Stuxnet, and even back into the late 80s and 90s, people weren't thinking about how their networks would be infiltrated or their systems would be infiltrated. And so a lot of those legacy systems, which are still out there, have potential vulnerabilities through what we call backdoors. So people would leave backdoors in because there were no off-the-shelf at that time tools or diagnostics. So people would leave backdoors in that they could go in, they could type in some keystrokes, ASCII, whatever, some code, and they could then get access to the system to be able to look at the controllers and look at the buffers and see what was going on. So those vulnerabilities could still be exploited. And this is what it's talking about in terms of the intentional attacks on the hardware, as well as the unintended events resulting from human error. So again, this is referring to potential systematic issues. Then you need a description of the potential consequences resulting from these events and the likelihood of these events, similarly to how you would look at it from a PHA point of view or a HAZOP point of view when you're doing your risk analysis. You do the same thing here. And having a tool designed to do this is helpful. We have a tool called CyberFacts, which we use for doing these types of risk assessments. And then consider the various phases. Same thing again, as with the safety life cycle in 08 and 11, we have a similar life cycle for cyber. So again, you'd be looking at an analysis phase, a design and implementation phase, and then an operation phase. And right now, the standard suggests that you do the cyber assessment and the vulnerability assessment at the beginning, but also you should really do one prior to startup. And we recommend that you do one, if you haven't done one before, do one during an FAT, because it's on the shop floor and it's easy to rectify any problems that are found. But then you should also do one before you start up, because during installation and commissioning, people are in there with laptops, with thumb drives, changing configurations. There's all sorts of potential vulnerabilities and potential threats that could be recognized there. So you could be starting up and not know that you've been compromised. And then you look at the determination of requirements for additional risk reduction. Similarly, with safety, we would look at, okay, what do we need to do? Do we need to put in SIFs? Here we would be looking at, do we need to put in such things such as firewalls? Do we need to put in some form of physical segregation, such as making sure that sensitive equipment can't be accessed either through some sort of keying mechanism, through some sort of biomechanism, or just having it locked away in a cabinet or building that requires access permissions. And then a description of all the references to information on the measures taken to reduce or remove the threats. So here again, documenting what you've done to achieve that. So that's in the new standard. And then they have additional notes. And then they say that there's guidance related to SIS securities provided in the TR-84. That's a separate working group that is currently looking at how to assign what's known as security levels. And these are covered in the 62443-2-1. The information and control of boundary conditions needed for security risk assessment are typically with the owner operating company or facility, not with the supplier. So what this says is that it falls on the end user. The onus is on the end user to make sure this risk assessment is carried out. You can as an end user require suppliers to provide some sort of evidence or certificate to show that their product has been rigorously tested to make sure that it's as far as possible free of any potential cyber threats. And that's very important to understand. So just remember, that's where the onus falls on the end user to be able to do that. Excuse me. So the SIS security risk assessment can be included in an overall process automation security risk assessment. Here again, what tends to happen is that instead of just looking at the SIS, you want to look at the overall network, because again, if you've used the BPCS as a layer of protection, then you don't want that to be compromised either. And there may be things such as your historian. You may have a PI historian, you may have a central historian. How is that going to be protected? And usually what happens is you will create some form of demilitarized zone where you'll have everything in there, and that's usually the place where you'll be interfacing between your process control network, your OT side if you like, and your IT side, where you're now going into the plant network or to the corporate network and the wide area network. And here again, the SIS security risk assessment can range in focus from an individual SIF to all SISs. So here again, if you're going to be looking at that, you can look at it on an individual basis, or you can look at it from plant-wide or company-wide for that matter. And so this is important to bear in mind and applies to the end user. So the onus is on the end user, not on the supplier. Like I said, the end user can insist on having suppliers provide some form of certification if it's an intelligent field device or it's some form of type B device. So the point being is that as part of the assessment, as part of the feed, the final phase you would do is to look at the assessment. And then here again we're looking at the scope and purpose of the system. Is it an SIS? Is it a BPCS? What's it going to be doing? Is it just a SCADA network? What's the physical and environmental security requirements? Do we actually have programming stations locked away? Do we have switches in boxes that are not accessible? Have we switched off empty, unused ports, etc., etc.? And that would come in under the general cybersecurity requirements. And then you'll look at the zone and conduit specific requirements. What we mean by that is that you can create zones or areas, functional areas, and you can manage the data that flows in and out of those. So that if your SIS is connected to your PCN, you can allow the SIS to read data from the BPCS and even write data out. And you could allow the BPCS to read data from the SIS but not to write back to the SIS. So you can control through that how data flows. So why is this important? Well, because modern SIS systems and BPCS systems communicate via a process control network. We do use a lot of Ethernet and open standard protocols, and of course these provide vulnerabilities. If you compromise your SIS, it could have drastic effects because you could lose your safety function capability. If your controllers are compromised, you've got no ability to safely control what's going on. So from management's point of view, and we often come across this when we talk to the managers, that this is, well, we haven't had an incident yet, so why do I need to do this? But the point being is you've got to understand the history, and there have been recent events. There was a steel mill in Germany, I believe, that got hacked and actually resulted in fatality. So it is real. You need to understand the drivers here. Most of the time we're using commercial off-the-shelf technology, which is readily available, but also has potential vulnerabilities. Remote access. Many systems provide remote access via some sort of Wi-Fi connection, or even an OPC connection, or some other network connection. Those could also be points of vulnerabilities. Some people think, okay, my SIS isn't connected to the PCN, I'm air-gapped, I'm golden because I've got antivirus. Well, antivirus is only 30% efficient at best. And if you think you're protected, think again, because your SIS will still have RJ45s. There will still be ports that could be vulnerable. You may have USB access, you may have disk access, etc. So you've still got potential vulnerabilities. So what is actual ICS, Industrial Control System Security? The point being is that you're trying to prevent intentional or unintentional interference with the proper operation of your system. And you can do that a number of ways, through computers, networks, operating systems, applications, other programmable configurable components of the system. And these are things like firewalls. There are lots of those available. And it goes by many names. People sometimes refer to SCADA security, they refer to PCN security, industrial automation and control system security, control system cybersecurity, industrial network security, electronic security for industrial automation and control systems. So any one of these could be applied, but it basically means the same thing. What we're trying to do is prevent intentional or unintentional interference with the control of our systems. So what are these vulnerabilities? We've mentioned commercial off-the-shelf technologies and protocols. These things, for example, the integration of technologies such as Windows. We all know how secure Windows is, don't we? SQL and TCP/IP. So process control systems are vulnerable to the same types of viruses and Trojans that affect the IT systems. The only difference is in the IT world, if you do get a virus, then they may have to take some servers down, you may lose email, you may lose some form of communication. It's not necessarily the end of the world. You do that with a control system, especially an SIS, and that's a different story entirely. So you've got into enterprise integration now. Here, this is where you have your corporate or plant-wide networks, and sometimes even public networks, connected. So you have these types of connections, plus you've got a lot of legacy systems that have been out there for quite a few years, some maybe even 20 years. And those weren't designed to being subjected to the types of stresses that you can get with some of these events. Remote access is very popular. A lot of the old systems allowed for remote access, so operators or even engineers could go into the system remotely and fine-tune process parameters and make changes. So again, these are potential vulnerability points. Public information. A lot of the logic solvers do have information that's available on how to access their ports, their portals, and there are websites that publish these, and they're readily available. And sometimes you can see that these things are completely open and vulnerable. So what are the pathways into the control network? So you could have through the internet, of course. Internet is used very widely, especially with LANs and WANs. You can also have misconfigured firewalls. A lot of the times when we go in and look at networks, we find things like the switches, for example, aren't configured properly. There may be a 16-port switch and maybe 5 of them are being used. The others are still enabled. They're not disabled or switched off. Now that has two effects. One, it leads to a vulnerability, but secondly, it's a performance issue because even though the ports aren't being used, it's still taking horsepower from the processor inside the switch. So those should be switched off. Firewalls, oftentimes the rules are not well defined and they're not configured correctly, so you may be thinking that you're protected, but you're not. And of course, infected laptops, that's another classic one where people go in with a laptop to make changes. They didn't realize that their son or daughter had been playing with it the day before and had loaded up some disk which had a virus on it, and now the laptop was infected and they've just brought it in. Some of the older systems, even though they don't use them anymore, they're still connected, have modems. So if you that's one of the other things to look for, is if those modems are there, they should either be removed or disabled if they're not being used. That's why it's very important to inventory what is on your network. Here again, when we've gone in and done assessments, the first thing we do is we look at what's inventory, what's on the network. And most of the times with the older plants and the older networks, people don't know because there have been so many changes over the years, they don't know exactly what's connected to the networks. And the other thing, of course, is that having circular networks where you think you've got a star, but actually you've got a loop. And these external PLC networks, here again is another vulnerability. So there's so many potential vulnerabilities that need to be considered. Obviously, from the SIS point of view, we are controlling through the SIS and the BPCS or SCADA systems real-world devices and processes. If you have a failure due to a cyber incursion, it can lead to some serious consequences. You could lose production, you could have service interruption, you could have off-spec or dangerous product, you could have environmental releases, you could have sickness or injury, or worse still, you could have death. And the older ICS equipment has been shown to be more sensitive to excessive network traffic. So these things have to be considered. Like I said, in the 80s, we would think, who would bother to hack into a control system? As we moved into the 90s and moved into more open platforms with Windows, we started becoming a little more aware of that, but then in the 2000s, cyber started being discussed much more seriously. The SP99 committee was set up to work on that, and it all came to a head when, of course, Stuxnet hit. And since then, there have been numerous examples of attacks and problems. As a result, there are several working groups that were working on this. Ultimately, these all came in together and formed what's now become the IEC 62443 cybersecurity standard. And this is the one that is being used today. It's heavily based upon the old SA 99. So, from the cybersecurity point of view, we need to control threats. We need to safeguard ourselves, especially our SIS, because these things have happened and we have seen problems. It's only a matter of time before something really bad happens. Obviously, the IEC has recognized the importance of protecting safety instrumented systems, and that's why they've updated the 61511. And end users now are going to have to show compliance with this new standard. Obviously, the brownfield sites and the greenfield. Greenfields are easier, of course. Brownfields, well, as I've said, the best time to do that is if you're coming up to revisit your PHAs. That's a good time to do it. Or if you've just done your PHAs, then it's good to just have a vulnerability assessment done to see where the potential threats are, and then to put together a program and a plan of how to mitigate against that. So cybersecurity and functional safety now are going to be closely aligned, and they have similar life cycle requirements. Understanding where your control system vulnerabilities lie is key, including your communication network. So you need to understand that, and the best way to do that is to have some form of vulnerability assessment or gap assessment done, which can be done fairly quickly and is not going to break the bank just to have a gap assessment, and then you can build a phased program in how you're going to fix or how you're going to mitigate, and that can be phased over a period of time and allows you to budget to do that work. Use of tools and checklists, of course, can help with consistency, and there's very good guidance in the 62443. Here again, you need to have competent and well-trained people that are looking at your threats and vulnerabilities. You can use, of course, independent third parties to conduct these vulnerability assessments and to help identify the weaknesses and plug gaps. So that's it in a nutshell. If you have any further questions, then let me know. I see we do have some questions that have come in. It says, during an EPC, who should perform the security risk assessment? Either the contractor or the end user? That's a good question. The EPC, if they're putting together the system, they would be the ones that should bring in somebody to do the assessment, because they are considered a part of the end user. Do you have examples of the documentation of assessments and risk reduction measures? Yes, we do. If you want to contact me via email, I'll be happy to share some things with you. What else do we have? Trying to get acceptance and buy-in, management buy-in, can sometimes be difficult. Yes, that's true. Is there a framework which is to be followed? Well, the point being now that the standard is out and it says clearly that this has to be done. So managers, if you're OSHA PSM or COMA, then you need to follow best practice, and this is being recognized as best practice. So management can either be on board or not. If you're following, you're following. If you're not, well. And again, for instance, in the world of IT, there are many frameworks such as NIST, COBIT. Yes, that's true. Well, now we have IEC 62443 and IEC 61511. So 1511 basically says now, this is what you've got to do. So it's up to the end users to be compliant or not. If there happens to be an incident that's traced back to a cyber incursion and nothing was done about it, then of course there's going to be consequences. Okay, well, if there are no more questions. I thank you all for your attendance. I apologize for my voice. Please email me with any questions that you may have, if you think of any afterwards, and I'll be happy to answer them. So thank you all. Enjoy the rest of your day.